Welcome to a very important day for us as we move through pre-cal. What we've done in the past is we identified functions. Specifically, we did that in our last lesson. Today, we're going to look at things called like domain and range. It's very important. We'll also talk about y-intercepts and zeros, which is basically x-intercepts. That's what that is. And we're also going to talk about symmetry, even and odd, and we'll talk about how it can be rotated or flipped, things of that nature. Let's look at some of the vocabulary. A zero, like I just said, is anything that's an x-intercept. That is also known as a zero or a root. Both these words mean the same thing. Line symmetry might be if something reflects. Say if it reflects on y equals x, or a line, or the y-axis, something like that. Point symmetry is if it kind of looks like a rotation, if it rotates on a point. Even would be when we have something that is of the form that if we had, excuse me, I put y, let me change this to f, that f, some function of x, if it's equal to the same value, if it's but negative, then that's an even function. That's even. And another way of thinking about it is it reflects over the y-axis. And then finally, an odd function is where a function with any value is equal to the negative of the function when you take the negative of the value. Okay, this is where it'll rotate on a point or reflect on the point. Reflect on origin. It'll kind of look like a rotation. So we'll see those as we go through today. Let's look at an example. It says the function f of x equals negative 5x squared plus 50x approximates the profit at a toy company, where x represents the marketing cost and f of x represents the profit. So this is profit. Oops. Profit, this one's the cost. The x is the cost. All right, both costs and profits are measured in tens of thousands of dollars. Using the graph, estimate the profit when the marketing costs are $30,000. That means that x equals 30,000. Now, since these are measured in tens of thousands, that means that 2 over here is actually equal to 20,000. 4 would be 40,000. So estimate the cost when x equals 30,000. That's the same thing as saying x equals 3 when you divide by 10,000. Okay, so when x is 3, which is here, we can estimate our y value. So it looks like to me it'll be just above 110,000s. All right, now it says confirm your estimate algebraically. So we're going to estimate that f of 3 is approximately, I'll say it's a little bit more than 100. It looks like these are counting. This would be 125 here. So I'm going to say maybe around 110. Now let's confirm it algebraically. The way we do it is we plug in to the equation that 3n. So we take our equation from up above here at negative 5 and put in 3, we'll square it, plus 50 times 3. Now if we do the math, we need to follow PEMDAS so that 3 gets squared first, which means that becomes 9. So we have negative 5 times 9 plus 3 times 50 is 150. This, when we simplify, becomes negative 45. We're going to add 150, and we get a value of 105. So the actual profit, when you turn that into 10,000s, would be 105 and then 4 zeros after. This is the actual value here. It'd be 1,050,000. Okay, here's a second example. Same problem, but this time, what's different is it says use the graph to estimate the marketing cost. So we're going backwards when the profit is 1.25 million. So now we go to 1.25 million. So 125 is here, which is what that is when we divide it by 10,000. And when I look at that value, it's right here, and x equals 5 there. So it appears that x would equal 5, or the marketing cost is $50,000. To confirm this, we could set this in for f of x, and you could solve algebraically by saying 1,250,000 will equal negative 5x squared plus 50x. We can move this over, and we could solve. For the sake of time, I'll just tell you it is true, so we get 50,000 as our answer.